Let's explore piecewise functions. A piecewise function is a function built out of multiple formulas. Let's see exactly how it's defined. So this is a piecewise function. So this function is given by these three formulas, and each formula has its own domain. This first formula, 2x plus 5, has the domain x greater than or equal to minus 2 and less than 1. The second formula, 6, has domain simply x equals 1. And the third formula comes with the domain x greater than 1. So the domain of f for a piecewise function, the domain will be the union of the individual domains. This is what we are using for the domain of the piecewise function. So here, this would be the union of these three domains, which is simply all real numbers greater than or equal to minus 2. So there's the domain of the piecewise function. Let's evaluate this function as some inputs, some possible inputs. Which of these is actually not an input? F evaluated at minus 5. Well, to find the output, we would find the formula for which negative 5 is in that formula's domain. We see that negative 5 is in none of the three domains. So negative 5 is not in the domain of f. How about f of 1? Well, 1 is in the domain for the second formula. So we get 6, 4. 4 is in the domain for the third formula. So the output is 4 squared, or 16. And let's do minus 3 halves. Minus 3 halves is in the domain for the first formula. And when we plug it into 2x plus 5, we get out positive 2. Now let's look at the intercepts. What about the x-intercepts of f? Well, to find these, we need to look at each individual formula. Let's take the first formula, 2x plus 5. So let's see, when is that equal to 0? It equals 0 when x equals minus 5 halves. So this tells us that we have the following as an x-intercept. Except it's not an x-intercept of f because minus 5 halves is not in the domain for 2x plus 5. How about this next formula, 6? Well, there's no solutions here, so this doesn't give us any x-intercepts. And finally, x squared. Set x squared equal to 0, and we get x equals 0. So this should tell us that 0, 0 is an x-intercept for f. We just have to check that 0 is in the domain for the third formula. It's not, though. This is not an x-intercept for f. X equals 0. Again, this is the domain of x squared in this problem. So we actually have no x-intercepts. And we'll see this when we graph f. How about a y-intercept? Well, 0 is in the domain of f. And f of 0 is equal to 2 times 0 plus 5, which is 5. So there is a y-intercept, and it's 0, 5. Let's graph this function. To graph f, it's best that we graph each of the 3 individual functions. That is, the functions defined by the 3 individual formulas. Start with the first formula. So the function that formula defines has this as its graph. And we're interested in this formula for x's greater than or equal to 2 and less than 1. Let's use a solid line. The vertical line x equals minus 2. And I'll use a dashed line for the vertical line x equals positive 1. So what we're interested in is this piece of the graph. This is the point 1, 7. And over here is the point negative 2, 1. And now for the second formula, 6. We're interested in on x equal to 1. So the function defined by the formula 6 has this as its graph. This horizontal line. And we're interested in this graph when x equals 1. X equals 1. I'm going to include this point. And then finally, the third function, x squared. Well, this formula x squared defines a function with this as its graph. And we're interested in this graph for all x's greater than 1. I'm going to use a dashed line to remind myself that I do not include the point on the graph above 1. Open circle. So we're interested in this piece of the graph. So the 3 red pieces concatenated together will give us the graph of f. Here's what the graph of f looks like. Let's work left to right. So the first formula gives us this part of the graph of f. This right here is the point -2, 1. This is 1, 7. And then when x equals 1, we had the middle formula. And it gives us this piece of the graph of f. This is a filled-in circle. And then finally, the third formula gives us this piece of the graph of f. This is the point 1, 1 squared, 1, 1. So this is an open circle. The point right there is not included on the graph. So here is the graph of f.